So, hello, my name is Birger Evenburg. I'm working in the Beckhoff office in Lübeck for the wind team. And today's topic is how to create a flexible measurement campaigns with TwinCAT FlexMeter. TwinCAT FlexMeter is a part of the TwinCAT Wind framework. The Wind framework is a modular framework which provides our customers control technology and industrial expertise for wind turbines. For a flexible data locker, PC-based control features are used. On one system, our TwinCAT real-time is installed, and as an operation system, you can use Windows 10 IoT, an example. Beside to the operation system, a database is installed to store the logged data. And the I/O modules can be selected to fit exact our or your measurement task. An overview about a measurement campaign. A wind turbine can be equipped with different sensors. The data will be collected from the TwinCAT FlexMeter and an industrial PC from Beckhoff and forward the data to a local database and or to an MQTT broker for the post-processing. The field of application is that we have an Beckhoff CX, an example. On this card, we have our system installed. This is the Windows 10 an example where we have our TwinCAT real-time installed. Here we can have an extra SSD for the data storage. And on the right side, we can put our terminals in the order we need and the type we need. And if we have a couple of different measurement campaigns, the hardware is changing from every measurement campaign to another. So in the end of the day, we have a lot of different hardware setups. Even the controller can change, or the form factor of a controller can change as well. And for each setup, we need a hardware setup in TwinCAT. And the solution to get this easy is the TwinCAT FlexMeter. So we defined a couple of targets which we like to fulfill with the FlexMeter configurator. First of all, it should be easy to use. So no programming is needed, just configuration to create a measurement campaign. It should be based on TwinCAT. So TwinCAT FlexMeter creates a TwinCAT project hidden from the user and can be added later on. So this is a part of the extensibility. You can extend a TwinCAT project created by the TwinCAT FlexMeter. And as well to the configurator of TwinCAT FlexMeter, you can add a new terminal, or somebody has the audio still on. And next to the FlexMeter configurator, we can add a couple of new tasks. So you can add new terminals, or you can create a preset of a new sensor just via XML configuration files. And the data should be sent or can be sent via standardized database access, an example to a SQL server from Microsoft, or via MQTT to an IoT Edge broker, an example. How we can access to this system. So first, how we can build a flexible measurement project. First of all, we have to build up our field bus as we need the field bus. Second, we have to wire the sensors. Third, we have to connect with our engineering system via network cable to the controller. On our engineering system, we have to install TwinCAT engineering and the FlexMeter framework. And the last step is creating for each channel a data point that we can log the data to a database or an IoT connection. Sometimes we are not able to have an engineering notebook with TwinCAT installed. So we have a second possibility to configure a system. So we are using PC-based control features to get everything in one system. The steps are pretty much the same. First, we have to build up our field bus. Second, we have to wire the sensors. Third, we have to open TwinCAT directly on the controller. So we are hooked up via USB and DVI, monitor, mouse, keyboard. And then we can use this Windows operation system next to our real-time for the user mode application of the engineering process. So we can open TwinCAT FlexMeter on that controller and can do every configuration on one system. Overall, the TwinCAT FlexMeter can be defined as a template creator for a TwinCAT project. So the first step is the user has to do inputs into the FlexMeter graphic user interface. And in the background, the configurator of FlexMeter is creating a standard TwinCAT project, which will be, after the configuration process, sent to the controller. Later on, this project can be extended manually. You can open this project directly in the development environment, and you can add an example, a PLC, or a different other C++ objects for more data post-processing, an example, or data reduction. In the end of the day, we are using for TwinCAT FlexMeter our modular runtime, as Niels explained before. So in our example, we are using a lot of different TCCOM objects, which are called directly from our real-time. So we have base objects like the database access or storage or capture raw data and capture statistic data. And next to the standard TwinCAT Wind framework functionalities, we have instances for each channel from FlexMeter to log data to the database. So for a couple of analog channels, we need a couple of automatic created instances of a FlexMeter analog object, or for digital data as well. And here an example, you can see you can add your own PLC as you like. Or even you can create your own TwinCAT FlexMeter objects if you need some post-processing stuff or data reduction stuff or mathematics in the real-time world. But how does the data acquisition in the Beckhoff world works? So Beckhoff EtherCAT terminals can have one input up to 8 or more inputs. An example here, we have one channel input, which can create us one data point in the FlexMeter world. Or we have here a second terminal, which has 2 different digital inputs. Then we have a 4-channel input device or an 8-channel input device, an example. And the data recording modes are, if we have a base time, an example, FlexMeter is using a base time from a millisecond. We have terminals, they can log data or record data once per cycle. So in this case, this terminal provides us data with a maximum sample rate of in kilohertz. If we need more speed or more data, we can use a Beckhoff feature, it's called oversampling. This feature provides each millisecond, an example, 10 values, which are separated evenly in this frame. So the terminal is creating always in the same distance of time, a data point, and send after a millisecond 10 data points, an example, to the logger. So we can reach with this terminal up to 10 kilohertz sample rate. And we have another recording mode. This recording mode is the timestamp mode. So the terminal gets a digital input in this example, gets a rising and a falling flag. Next to the date of the input, the terminal records a 64-bit timestamp for the rising and falling flag. And so you can use these very exact timestamp to calculate other data like rounds per minute. Next to our standard terminals, we have the EtherCAT measurement modules. They are faster than our standard terminals, up to 50,000 samples per second. So we can reach 50 kilohertz on FlexMeter with these terminals and with a bit resolution of 24. Next to the good synchronization from distributed clocks, every value which is recorded with an ELM terminal gets an exact timestamp when it's recorded. And the measurement accuracy of 100 ppm and better is pretty good as well. Next to the data recording, a lot of Beckhoff terminals and the EtherCAT measurement terminals supporting diagnostics or live diagnostics of the value itself. So for each value we have, we get like the metadata. Is that value okay and correct? So if we are having an overrange or underrange or a break detection of the wiring, in example. Next topic is the data storage, how we can store the data. In this example, we have an CX, which is configured with an operation system, TwinCAT is installed, a FlexMeter project is activated on that device. Here we have an SSD extension kit, so we have more space for our data to store the data directly on that system. So maybe we do not have a network connection, or the network connection is not fast enough to handle 50 kilohertz sample rates for a couple of channels. So we can store the data directly on the machine. And next to TwinCAT on this Windows system, we can install a standard Microsoft SQL Server database, an example. So this allows us a couple of different storage or data processing or data transport methods. First, we have our TwinCAT real-time, and we are just logging into a database. The second mode is just logging data to MQTT, but the maximum sample rate is kilohertz for a channel, an example. Or we can do both, just sending all the data we have downsampled to a kilohertz via MQTT, and all the high frequency data can be stored directly into the database. So in the last step, I like to show you the workflow, how to configure a flexible measurement project without programming, just configuration. First, we are opening the TwinCAT FlexMeter configurator. This is this application. We can define a project name. This will be, in the end of the day, the project name of the TwinCAT solution, the Visual Studio solution, and we can select a path. After we selected the path, we have to select the target. So we have a couple of checkbounds if the checks if the target is available, is all licensed correctly, and if it's a Beckhoff device. And then you can select this target. And after you select this target, you can trigger a field bus scan. And the field bus scan will show you the terminals in the other list or other type of list as TwinCAT. So we have the different tabs for different stations. We are, an example, separated by an EK 1100. And then we can click on a terminal. We can see this ELM terminal is a 2-channel terminal, and we can select for each channel an input driver. An example, we can choose for this terminal an analog extended driver with extended options. And then we can just configuring the system. So we have to define a channel name. This will be the unique identifier in the database and in the MQTT messages. Then we can select the unit. So this will be the raw value. Then we can select the sample rate. We can statistic calculation like minimum, maximum, and standard deviation. And then we can select, because this is a multi-purpose measurement terminal, we can select an interface, the range for the data recording for the AD conversion. And we can select a couple of hardware filters as well for that terminal. And all these options will be just displayed if this option is available directly for this terminal type. And maybe these are still too much options. We can put these options together to a template. You just have to select then the name, the sample rate, and that's it. And after we save the configuration, we can activate the configuration, so the project will be created and transferred to the system. And then we have our running data recorder, data logger, which is sending data to the cloud and to the SQL server. Thank you very much. Any questions?